Part 2, let me show you 2 more examples. I've shown you all 3 cases. You might think I'm done. But I just pointed out that in that last case, we were secretly recycling and using the 3-part test twice. Let me emphasize that by showing you a couple of examples where really interesting things happen at that second stage. Okay, you apply the 3-part test once, the bottom 4 plus 4 minus 8 goes to 0, top goes to 0. So we're in that interesting case where we better try to do some algebra and rewrite this or else we're sunk. But we know how this bottom factors. It's a perfect square. That's not a coincidence. We rewrite. And then we look at it again. And we use the 3-part test again because we're doing the limit of a quotient. And now it's non-zero over 0 again. And so now it's going to go to plus or minus infinity. If I didn't change the problem a little bit, I couldn't say any more precisely, so just to be different, let's say it's the limit as x goes to 2 plus. Now, that's the thing you're not allowed to do as a student. That's a teacher move. I changed the problem so that I could get a more specific answer and say a little bit more about it. That's not something you're supposed to do as a student. Okay? Now, x is a little bit bigger than 2. X minus 2 is a little bit bigger than 0, but really close to 0. So I'm getting 1 over a very small positive number. That goes up to plus infinity. So you shouldn't interpret the 3-part test as saying, in the 0 over 0 case, I will never get infinity. That's not true. What's happening here is this is exactly the kind of case I alluded to a few minutes ago, where it's small over very small. X minus 2, if x is a little bit bigger than 2, say it's 2.01. This is going to be 0.01. So if x is 2.01. Again, now I'm just kind of freehanding, kind of get the idea. This is not part of the derivation. 0.01, oh, but this is 0.01 times 0.01. If I multiply a small number by itself, I get a very small number. Small over a very small number actually is large, because a very small number can go into a small number a lot of times. And that's why we're getting the plus infinity. Okay. Again, this is great for getting intuition. You got to transition out of this stage at some point when you're writing your stuff down. It's not something people want to see as a justification. If you're trying to explain it to your friend, please use it. But don't write it on an AP. Okay, well, let's see. Is there anything else that can happen? Just to kind of complete our little tour. Well, there's even more funky stuff that can happen, but it's not super qualitatively different. It's sort of more variations on smaller and smaller and smaller. But let's look at this one, because this is different enough to be interesting. Okay, if you plug in top and bottom, we've seen both of those guys before as x goes to 2. They both go to 0. So we factor. We do see a cancellation. That has to happen with polynomials. If they're going to 0, the reason they go to 0 is they have a factor that goes to 0 at the point you're interested in. That's always going to happen, as long as you can do the factorization. Okay, so now I'm just going to rewrite it without that canceled factor. And as always, I'm going to, that's a minus 3, sorry. That's a minus 3. That was my bad. I'm going to rewrite it and again use the 3-part test. Always back to that when the limit of a quotient. I think I didn't emphasize that enough in class. Now, the top's going to 0 and the bottom's not going to 0. This isn't something you have to treat specially. This is something that's one of the biggest mistakes. 0 over 1. Oh, it does not exist. You can divide 0 by something. That's always just 0. You just can't divide by 0. It's not that 0 is illegal in the numerator and the denominator. It's just illegal in the denominator. Okay. So this is going to be perfectly fine. This is actually case 1 of the 3-part test. The bottom is not going to 0, no matter what the top does. You can always just separate that into 2 parts. And because the top's a polynomial and the bottom's a polynomial, it's just going to be fine. And it happens to be the top evaluates to 0. But it's still a little bit special that this is going to 0. 0 is a pretty special number, even though we didn't have to treat it specially. I just wanted to do this case because it's opposite of what we just saw in example number 4. if x is like 2.01, then here you're going to get 0.01, moderately small. But here you're going to get 0.01 and those guys cancel. Here you're going to get minus 0.99, which is medium and happens to be negative. Here you're getting 0.01, small. So this guy together is very small. This guy together is just medium small. And that actually goes to 0. So these guys can go to 0, they can go to a non-zero finite number, they can go to plus infinity or minus infinity. It's really up to them, and you have to just do the algebra and do the simplification until it's simple enough to make that choice, to see where it's going. Okay, hopefully that's a good stock of examples for you guys.